Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2. We will present about slope remedial technique using combination of retaining wall and drainage. This is our group member. First, Noorasyikin Binti Mohammad. Second, Nur Elisa Binti Matkolozi. Third, Siti Azlin Radiah Binti Raizak. And last is Nurul Halawati Binti Yusuf. This is table of contents. I will present about introduction. For the introduction, a slope failure is a phenomenon in which slope collapse abruptly due to the earth's weakened self-retainability as a result of rainfall or an earthquake. Many people dare to escape a sudden collapse of slope if it occurs near a residential area, resulting in a higher rate of fatalities. A landslide is a slope failure where soil mass on slope moves slowly along the slip surface downward the slope under the influence of groundwater and other causes. Landslide can cause serious damage because it occurs over a large area and moves a large amount of soil mass in general. In the present study, a method of slope remedial technique using the combination of retaining wall and drainage are introduced to help the slope stability at the slope failure area.
My name is Noorasyikin Binti Mohammad, metric number DF190034. I will present about literature review. Theory for slope stability analysis. The ability of slope soil or rock slope to endure movement is referred to as slope stability. In soil mechanics, geotechnical engineering, and engineering geology, slope stability is a topic of study and research. Analyses are primary focus are determining the reason of a slope failure. When these variables are integrated over a possible or real sliding surface, the ratio between available shear stress and active shear stress determines the slope stability. This safety factor compute along any potential sliding surface running from the top of the slope to its to determine stability. A previously stable slope can be influenced by a variety of predisposing variables or processes that reduce the safety factor. Hydrologic events such as heavy or prolonged rainfall, rapid snowmelt, progressive soil saturation, or an increase in water pressure, the slope are all factors that can cause slope failure. Type of slope failure: translational failure, rotational failure, wedge failure, and compound failure. Translational failure: a slope is said to be infinite when the slope has no definite boundaries and so under the free surface contains the same properties up to identical depth along the slope. This type of failure can be observed in slope of layered material or natural slope formation. The term translation failure means the failure surface is parallel to the slope surface. Rotational failure: in the case of rotational failure, the failure occurs by rotation along a slip surface and the shape thus obtained in slip surface is curved. In the homogeneous soil, the shape is circular, while in case of non-homogeneous soil is non-circular. Rotational failure can be seen in infinite slopes such as Eden dams, embankment, man-made slope. Rotational failure may occur in three different ways. First, phase failure or slope failure. Phase failure occurs when soil above the toe contains weak stratum. In this case, the failure plane intersects the slope above toe. Second, toe failure. Toe failure is the most common failure in which failure planes passes through toe of slope. Third, base failure. Base failure occurs when there is a weak soil strata under the toe and failure plane passes through base of slope. For wedge failure, also known as a block failure or plane failure, generates a failure plane that is inclined. This type of failure occurs when there are fissures, joint or weak soil layer in slope, or when a slope is made of two different materials. It is more similar to translational failure, but the difference is that translational failure only occurs in case of infinite slope, but wedge failure can occur in both infinite and finite slope. Compound failure. A compound failure is a combination of translational slide and rotational slide. In this case, the slip surface is curved at two ends like rotational slip surface and flat at central portion like in translational failure. The slip the slip surface becomes flat whenever there is a hard soil layer at a considerable depth from two.
Assalamualaikum warahmatullahi wabarakatuh. My name is Binti. My metric number is TF190046. I will present about the proposed technique of slope stability. Okay, we have a two method to propose. The first one is retaining structure method, which is that quite expensive, but it is very adaptable. Second is a geometrical method, which is that simple and inexpensive, but it requires adequate space. And the last one is a drainage method that's usually used in conjunction with others. A drainage method are available in conditions where surface and subsurface drain are properly maintained. Application of any standard. We took for our technique of slope stability is using a combination of retaining wall and drainage. The most important consideration in proper retaining wall designs and installation is organized and counteracting the tendency of the retained material to move down slope due to gravity. For drainage, when surface drainage cannot effectively remove or intercept groundwater, subsurface drainage technique are required. A combination method of retaining wall and drainage systems. Where retaining wall is one of type of slope stabilization solution, will a drainage is to make up of concealing ditch or permeable pipework depending on the situation. It is technically effective and cost-effective technique for increasing the stability of natural soils and constructs uphill slope as well as lowering peak pressure against retaining walls. Okay, retaining wall construction, we have six steps. The first one is excavation, which is to prepare the surrounding area for the retaining wall by excavating it. Step 2, formwork. Set up the rough formwork. Make sure there is at least 14 millimeter of cover for the reinforcement. Step 3, reinforcement. It starts part in place. It's critical that they are properly positioned. Step 4, concreting. With the formwork with concrete, make certain that the starting bar are not moved. It's a good idea to double check the starter bar before the concrete hardness. Step 5, constructing the first layer. Okay, begin by laying the first layer of block. Place them over the beginning bar. Lay the back draining pipe once the first layer is complete. The last one is complete the construction, which is construct the walls to its full height, backfilling with clean stone and retaining it as you go. Adding a drainage system. A drainage system will include all of the components required to ensure that the substructure is properly drained, and may include open ditch, closed ditch with spike drains and stopwater, drainage pipes, channel and culvert. We have a four, which is a gravel backfill, which simply refer to the soil directly behind the wall. For proper drainage, the first 12 inches of space behind a retaining wall should be filled with crushed stone or gravel. Second, soil compaction is the most important for creating strength. 3. Pipe drains, also known as store drain, are porous pipes that collect water along the length of the wall and drain into the outside. With holes are opening in the fronts of the wall that allow moisture to escape.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Azradia binti Rohaiza. Here I'm going to present my part, which is combination method, retaining and drainage. Based on the study through the retaining wall method, the period of 6 months after construction, soil consolidation is steady, and the mechanical characteristic each of the tend to be uniform. For the permanent wall structure, the general lifespan is generally between 50 and 100 years. For subsurface drainage provide many long-term sustainability and investment. A useful life at least least 20 years may be predicted with proper maintenance, and some systems survive several decades longer. The human mistakes that regulate the maintenance phase are connected to imprudent slope monitoring, which include a lack of attention to repairs, efficient surface erosion control measures, and an efficient drainage system owing to closed drain. So next, inspection of the pipe on a regular basis and removal of any obstruction is important, since the pipe has to perform as efficiently as possible. So that's all from me. Thank you.
Okay, for the conclusion, to summarize, soil has always been vital to humanity, dating back to the dawn of time. Engineers work with soil on a daily basis, hence it is intimately tied to the field of civil engineering. When a certain amount of electricity is supplied to certain clays, they solidify, whereas Malaysian clays do not. It is a poor building soil due to its low strength, low yield stress, high compressibility, and low permeability. Clay is a challenging soil for geotechnical engineers since it produces problems in any structure, such as subgrade problem due to undesirable engineering features. Soil plays an important role in our construction process, as previously stated. As a result, it's important that the soil match our load-bearing requirement. We look at potential soil problems as well as the source of those problems. We also look into problem-solving techniques that could be used to solve problems. That's all from our group. Thank you.